quadratic equations in this video, but this time we're going to use the quadratic formula to do so. So far we've solved them by factoring, we've solved them by completing the square if you're watching the videos in order, we've solved them by graphing, and this time we're going to solve them using a formula. And in math, if we can use a formula to get our answers, that's always a good thing because the formula spells out exactly what to do with the numbers in order to help us come up with our solution. So the quadratic formula is this formula right here. It says in order to find the values for x, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now you might be wondering, we've been solving quadratic equations or factoring them at least for a while now, and nowhere have I ever seen an a, b, or a c in any of those equations. Okay, I can see I wrote something wrong already. Let's take this piece out of here because it's already in there. And let me get the correct thing written down. Standard form of a quadratic equation is some number times x squared plus some number times x plus c, which is a constant. So if you look at this, this is the standard form. This is the form that all of our equations were in when we factored. It's the form that they needed to be in order to solve a quadratic equation by factoring. And there's coefficients, there's numbers involved in the problem. That's where we're going to get the a, b, and c from in order to use the quadratic formula. The a is always going to be the number in front of the x squared. So whatever number is in front of x squared is going to be our a value. Whatever number is in front of the x term is the b value for our problem. And whatever number is the constant is the c value. Please make sure that if any of these have minus signs in front, that you take the minus sign along with it when you determine the values for a, b, and c. So in this first problem, I want to solve this using the quadratic formula. And granted, probably all three of these equations could be solved using different methods, but I wanted ones that were going to work out nicely. And the title of this is using the quadratic formula. So I'm going to show you how to use the quadratic formula to solve these quadratic equations. How do I know that I want to solve the quadratic equations? The title of the video says so, of course, but when the quadratic is equal to 0, that's usually a good indicator to you that your job is to find out the value for x that makes the left side of the equation 0. And I already have it solved, or I shouldn't say solved, I already have it set up so that on the right hand side or on one side of the equal sign is a 0. So the first thing you have to do is determine what the a, the b, and the c are for your problem. Because there's a 4 in front of the x squared, the a value for this problem is 4. Because there's a negative 5 in front of the x, that means that the b value for this problem is negative 5. And in the constant position, the number that doesn't have a letter, we have a negative 6. So these are the values for the variables that I'm going to plug into the quadratic formula that I have circled up above here. Now this sign in front of here does not mean that b is always going to be negative. And I'm referring to this sign right here. Whoops, sorry. Got to write faster. Okay, the negative. That doesn't mean b is always negative. What it wants you to do is it wants you to take the opposite of whatever your b value is. So in our case, b happens to be a negative 5. In a little bit, I'm going to take the opposite of that, which is positive 5. Now, you might remember from our previous videos that for solving quadratics, there was always 2 answers. And we only have one formula here. Well, the way that we're going to get our 2 answers is because the formula has this plus minus sign in it. That plus minus sign is going to allow us to get both answers doing this quadratic formula. Now I want to take b squared, and what I have to remember is that no matter what b is, b squared is always going to be a positive number. minus, which minus comes from the formula. The 4 comes from the formula. A is 4, and C happens to be a -6. So far I've used the top part of this, and I've plugged all the numbers into the appropriate spots for what they're equal to. And on the bottom of our quadratic formula, we want to double whatever the A is, and that happens to be 4. So now I'm going to clean this up, and I'm going to start to do some of this math that's involved. The opposite of -5 is +5. Let's see, -5 to the second power is +25, and that should always be a positive number there. No matter what you square, it's going to end up being a positive. Now I have a minus sign. I need to find out what 4 times -6 is. Afraid to open up a calculator on here. I don't know if you can see my calculator in your video or not, but I'm going to quick do 4 times 4 times 6, which gives me 96. And because the 6 was a negative, I know I'm going to get a -96. Okay, and then on the bottom, 2 times 4 is 8. So I do have a little bit more math I can clean up here. My 5 is good, plus minus isn't going to change. Inside of here, I'm going to do keep it, change it, and 25 plus 96 becomes 121, and I still have 8 on the bottom. The square root of 121 is 11. So my answer right at this point is 5 plus or minus 11 divided by 8. You might be wondering, you still need to get 2 answers. Well, the way I get those 2 answers is I'm going to do 5 plus 11, and then I'm going to divide that by 8. And I'm going to do 5 minus 11, and I'm going to divide that by 8. So 5 plus 11 is 16, and 16 divided by 8 is going to give me 2. So one of my solutions is x equals 2. And over here, I'm running into the other problem, so I'm probably going to have to erase some of my notes here. 5 minus 11 is -3. -3 divided by 8 is -3/8, and it is possible to get fractions for your answers. We've seen it before. So x equals 2 or x equals -3/8. And you can always test your solutions by plugging them into the original quadratic equation that you were given. Okay, I'm going to give you some time right now if you're copying this problem down before I start the next one and before I exit out. And the reason I have to exit out is because it kind of went into the next problem. So I'm going to take this part out and try to leave my answer in there. This has to go. Okay, next one. Again, I want to determine what my A, B, and C are. A is 4, B is 12, and C is 9. This time they're all positive, but that doesn't mean that everything's going to stay positive in the whole quadratic formula. We have to just make sure we're careful when we solve. Okay, so x equals the opposite of b. Well, the opposite of b is a 12. Opposite of 12 is going to be -12. Plus minus the square root of b squared. 12 squared, I showed you in a different video, is 144. Minus 4 times 4, because a is 4, times 9, because c is 9. All over 2 times 4, because again a is 4. So now my next step would be just to clean up some of this math. So -12 plus or minus 144. And again, I'm going to get out my calculator, which I don't know if it'll show up in your video or not, but I'm quick going to do 4 times 4 times 9, which is 144. And 2 times 4 is going to be 8. Okay, so I see something unique happening on the inside of the radical sign. That square root symbol, the technical math term for it is radical. And 144 minus 144 is 0. The square root of 0 is 0. So negative 12 plus or minus 0 all over 8. So now if I did like I did the last time, I did negative 12 plus 0 divided by 8, and then negative 12 minus 0 divided by 8. But hopefully you realize it doesn't matter which one I do, they're both going to be negative 12 over 8, or let's see, negative 3/2. So what this just tells me is this would have been one of my perfect square trinomials. My factors would have been both 2x plus 3 times 2x plus 3. So in the last problem, I forget what number we had underneath the square root symbol, but it was a positive number, and it wasn't 0, and we ended up with 2 real solutions. That number on the inside of the square root sign, the b squared minus 4ac, is known as the discriminant. And the discriminant in your problem can tell you a lot about your final answers. If the discriminant is positive, and I'm going to use a capital D to stand for discriminant, you know that you're going to have 2 real solutions. Just like we did in the first problem, we had x equals 2 or x equals negative 3/8. We had 2 answers. If your discriminant is 0, like it was in the second example, we have 1 real solution. Actually, we do have 2. It just so happens that it was the same one both times. Like right here, if I had kept this one going, it would be negative 3/2 again. So 2 answers, they just happen to be the same thing. And then the last possibility for your discriminant is that it could be a negative number, which then means there are no real solutions. It doesn't mean that there aren't any solutions at all. It just means that they're not real numbers. They're in the number system known as the imaginary number system, and you will learn about that in Algebra 2. Okay, I'll leave that discriminant stuff over there and give you about 8 more seconds to copy down the rest of 2 if you haven't done so. All right, let's move on to problem number 3. This is a little different scenario here. We only have 2 terms, but we still need to know an a, a b, and a c. So the number in front of x squared, there isn't one, so it would be a 1. The middle term that has the x on it is missing completely from this problem, so that must be that b is 0. And c is going to be 121. So now that I have my a, b, and c, I can start plugging them into the quadratic formula. X equals the opposite of b. Well, b is 0. 0 doesn't have an opposite. So I'm not going to put, I can put a 0 here if I want to, but it's not necessary. And then b squared is 0 again, minus 4 times a, which is 1, and c, which is 121, all over 2 times a, and that's a 1. I'm not going to put the 0. Let's see here, 4 times 1, that's 4. 4 times 121, I believe, is going to be 484, and it's negative because of that minus sign out in front. Now, if I were to go to my calculator, which I don't know the calculator that I'm using, how well it's going to help me. And if I try to take, let's see, we've got a 484 that happens to be negative, and I want to take the square root of it. I don't know if I'm using the right button or not. No, I'm not. So let's clear this. 484, and I don't know if you can see this in the video or not, but when I hit square root, I get an invalid output. Invalid output means, in this calculator, that I can't take the square root of a negative number. If you're using the yellow graphing calculators, error, I can't, invalid dimension is what you might get as your message if you take the square root of a negative. Can't remember the exact message. So this means that there are no real solutions. And you don't have to go through and punch that into the calculator every time. The minute you see a negative number underneath the square root symbol, underneath the radical, that's going to tell you right away, no real solutions. It's something you'll learn how to solve when you get to Algebra 2.